Hello everyone, I am presenting the Chaos Engineering IXN project, which is carried out in cooperation with Entity Data. I will start by giving some background on the evolution of microservices and how that architectural approach relates to scalability and resilience of software systems. Traditionally, applications were built as large monoliths where the application layer sits between the user interface and the data layer containing the entire application stack. This significantly limits scalability because in order to make a system highly available, the entire application stack has to be replicated across multiple servers, even if only a small part of the application is experiencing a high load. Microservices are an architectural paradigm aiming to tackle these issues by splitting the single unit into cohesive modules which are self-contained and operationally independent. These loosely coupled systems are easier to maintain and increase resilience through fault isolation and are more efficient due to independent scalability, meaning that if a microservice fails, it does not affect the whole system's availability, while at the same time resources are efficiently used since only the components that receive a high amount of requests need to be replicated. Next, we will dive into technologies that enable microservice architectures to fully leverage their advantages. Containers are a cloud technology which are minimizing overhead. They are completely isolating the application and its dependencies, making it extremely portable, resulting in effortless replication. Moreover, due to their efficient nature, they enable dynamic scaling of instances depending on the traffic. However, since large applications consist of large amount of microservices, it becomes increasingly more difficult to manage them. This is where Kubernetes comes in, that is orchestrating the different containerized services and automates processes such as dynamic scaling of instances or services and restarting instances that have failed in a minimum amount of time. So chaos engineering is an emerging testing technique that is enabled through the distributed nature of microservices. Chaos tools artificially can induce faults into the deployed application either by killing nodes or issuing network delays, etc. This can help identifying weaknesses in an application's critical services. Moving over to the implementation, the idea is to build a simple web application consisting of 2 to 3 microservices that are containerized and deployed on a Kubernetes cluster. Various chaos tests should be then carried out to test the system's availability and show the benefits over the monolithic approach. Here is a quick overview of the architecture of the sample web application that has been built. It is consisting of 2 core services and is deployed on a Kubernetes cluster on Microsoft Azure. And this is an example of a chaos test conducted on that website. It is a pod service or instance kill in that case. The status of the test can be visualized in the chaos tools dashboard and the results will then be captured in the project report.